Hey everyone, it's Eugene here and welcome to another Recon 3D video. Today what I'm going to be doing is talking to you about documenting bullet trajectories and in particular using bullet trajectory rods for determining the angle at which a bullet may have struck a surface. So I'm just going to be using this car today as an example, but this could be through a wall, this could be through glass, it could be through anything that you can use with the rod. Now, normally when you use a trajectory rod, they come in two sizes, okay? So typically anyway, there's a 1/4 inch, which is about 6 millimeter, and then there's the 3/16 inch, which is about 4 millimeters. And this method is often referred to as the probing method, and it involves inserting the rod through an entrance and then putting it through an exit. So you got an entry, you got an exit, and you would secure this in place with trajectory cones. So basically you're gonna go like that, put that in, and then put this, put it through, and then on the other side like this. So basically this would be one side of the wall and this would be the other side of the wall. And based on the rod, you can determine what the direction of travel of the bullet was. Now, today we're not going to be doing that because I didn't shoot through this car and I don't want to do that. So I'm going to be using these magnetic mounts with these arms that you can just lock in place to simulate the rod in a particular position. And actually, you can use this method when it is a single bullet impact if you're using the lead-in method or something called the rocker method. So if you only have one impact and you don't really have an exit, you can actually just secure it onto the lead-in portion and lock it in place as best as possible with this here. So what I've got are a couple of things. I've got the rod through this little adapter. This is a 3D printed adapter that I've made for the end of here to hold it in place. And I've got another one here. Now the 3/16 is obviously a smaller diameter. So I have these two little white adapters that will help to secure it in place and not have it wobble around. Now, normally you can use just the rods yourself, and then, sometimes people will use like an angle gauge and then figure out where all this is, but we're gonna be doing 3D scanning and we're gonna do it with Recon 3D. So you can use just the rod themselves and then just scan it. But of course, the smaller the diameter of the rod, the more difficult it's going to be to resolve the 3D structure of that rod. So if you imagine something like a bicycle spoke or something that's very, very fine, you're not going to be able to pick up that data. It's just way too small to resolve. And so I'm going to show you what happens when we scan this in, using Recon 3D and then sort of trying to move around. And there is a technique to getting decent data. And so I'll show you how that happens as well. Now, regardless of what happens with the rods, often in laser scanning, it's very common to use trajectory spheres. So this is one here, and let me get another one here. There's another size. Here we go. And here's another one. So these are two different sizes. This one is 80 millimeters in diameter. This one is 55 millimeters in diameter. Now, normally with a terrestrial laser scanner, these would work absolutely fine. You can use these and you just put them on the rods. And for all the testing that's been done, these prove to be fairly beneficial. Spheres are very commonly used in laser scanning for registration for a number of different things. So using these targets gives you a greater surface area and you tend to get a great result. So you can use these with Recon 3D. However, there's a little twist to that, and that is that we have spheres with some texture on them. And this is just random painted texture, almost like a stone fleck or like a gray paint that comes out in a very uneven fashion. So let me move these close here and you'll see exactly what I mean. Something like that, and maybe something like this. So these spheres are very useful, especially if you were going to be doing just photogrammetry. Being able to see all this random texture on the sphere helps significantly to resolve the surface. If this was just a plain white sphere and you're photographing it from a number of different sides, it's very difficult to determine where the surface is because it's just white. There's not a lot of neighboring pixels or texture or random contrast that will help to determine where a point exists in 3D space. So having this random texture tends to help. So I think what we're going to do here is we are going to scan with just the rods. So we have the 6 millimeter, the 1/4 inch rod, and we have the 3/16, the 4 millimeter rod. We'll scan those, see what we get. And then what we're gonna do is we're gonna go back and we'll do it again, except we'll put the spheres on. So we'll put the 80 millimeter diameter spheres on the 1/4 inch rod, and then we'll put the 55 millimeter diameter spheres on the 3/16 rods. And you could actually put the larger spheres here too, it doesn't matter, but there is a little twist when you're using the smaller rod, and so let me show you that. There's these little adapters, and so this is the 3/16 rod. So the through hole for these spheres are both, okay, for the 80 millimeter and the 55 millimeter, they are both a 1/4 inch. And if you put it on a smaller rod, then this thing sort of wiggles around. You can kind of hear it in my microphone, I'm pretty sure. And so in order to secure that in place, what I've done is I've got these little adapters, and I'll probably get closer to the camera so you can see this, but it's just a little reducer, nothing special, okay, like that. And basically what I do is I put it into, let me put that close there. I put it up on this side, and then I put it through on this side as well. And it just fits into the little part that's sticking out here that has the 1/4 inch, and it reduces it to a smaller hole size right there. So now when I put this through, you see that it sits perfectly on the rod. And if I turn it, it's nice and snug. It doesn't wobble around. So that's what we're gonna do to this particular rod. In fact, I may just take this off and put it on there after. So I've got 2 of these with the adapters. Now the 1/4 inch, I don't need to do that because it's already a 1/4 inch diameter and the rod fits just perfectly. So let me get these scanned first. So I'll record this on my phone, and then I'll put the spheres on, and then we'll scan it again. So let's do the rods only to start with. Okay, I think I'm recording on screen here. I'm gonna get back into the Recon 3D app. So I'm gonna call this the spheres only test. Yep, that's good for me. Now, in terms of the settings here, what I'm gonna do is I'm gonna slide this right to 1 millimeter. I'm not doing a very long scan. This won't take me very long to do. Now, if I was gonna do the whole vehicle and such, that would be different, but what I'm gonna be doing is 1 millimeter, and I'm gonna slide the depth of reconstruction down to about 3 meters. And the reason for that is I'm not gonna be very far from this at all. So that is good for me, and I'm gonna hit go ahead, save. I'm not gonna be using April tags or anything like that. I'm just gonna leave this as is. So let me go ahead, and I'm just gonna do a quick scan. I'm gonna start at the bottom here, like that. And then I'm gonna move my way up. I'm gonna start moving the sensor towards the surface of the vehicle, and then I'm gonna come up, and I'm gonna get these rods like this. Okay, and now what I'm gonna do is I'm gonna go sort of parallel to the rod like that, and scan like this. So I'm gonna kind of go that way, and then what I'll do is I'll go to the other side like this, and I'm gonna do the same thing here. I'm gonna scan this way like that. Okay, and that's about it. That's about the best I can do. So I'm just gonna stop that right there. Okay, so that's good. I'm gonna save that one for later. And now what we have to do is let's switch this out so that we have the spheres on here, and then we'll do the same thing. We'll scan it again and then see what we get. So let me stop that and stop. And then what I'm gonna do is just set that up like that to make sure that I got the recording. Okay, I think I got it, great. So I'll put that in my back pocket, and let's go ahead and set this up. Okay, so we've got these set up, and I want to point out a couple of things. One is the location of the spheres, okay? So the front sphere is far to the front end of the rod, okay? So I try to get it as far forward as possible. I don't try to leave it back here and leave these close together. I actually want a large separation between the spheres, at least as much as I can. So I'm gonna move that a little bit more forward, and that will be good for me. Now the back one, because I want a wide separation, you would think that I would push this all the way to the back. Okay, so it's almost touching the car body, but that's actually not a good idea. And the reason is, and this is just through experience and a lot of testing, what ends up happening is that the space is so small between the sphere and the car body is that it has a very difficult time resolving the difference in the space between the two, and you just kind of get a mess in between there, okay? It just kind of like looks like it's all one thing. So if you separate this by a few centimeters and and you leave a bit of space, what will happen is you'll get a better resolve on the sphere itself. Okay, you get a more complete sphere and it doesn't blend in with the car body. Same thing goes on this one here. I've done the same thing. You can see I got this one far forward and I've got a little bit of space, just a couple of centimeters, you know, just enough to give it a little bit of space so that when you pass the phone over and you're scanning, it can separate the difference between the two. Okay, so that's good. Now, in terms of scanning, I'm going to do about the same thing that I did with the rods before. That's a little bit loud. I'm going to wait. Okay, so in terms of scanning technique, what I'm going to do is I'm going to pass over this. I'm going to try and get the spheres from different angles. So I'll try to sort of scan parallel to this side, to the rod. So I get the side of the rod. I'm going to try and scan from up top, and I'm going to pass the phone sort of along this way. And then I'm going to try and get it somewhere along this way as well and capture this side. Now I could try to get low and get underneath or whatever, but we'll just do the top half right now. And you'll see you'll get enough of the rod and enough of the spheres that you'll be able to work out what the trajectory is. So if you get about half of the sphere, you're absolutely fine. Most software, whether it's Ferrocene, Ferrozone 3D, even Cloud Compare, will detect spheres of this size, and so you could put them in place. And the idea here is obviously that if you calculate the center of this sphere and this sphere, it should coincide with the center of the rod, and so that's the way that would work. So let's get going here. I'm going to record this again. Let me bring that up. I'm going to record here. Let's start. And sorry about the wind. And looks like that's going. Looks like everything is good here. So now I'm going to bring up Recon 3D. Okay, so this one we're going to call this the two spheres, because we have two sphere sizes and two sphere test, and that's good for me. All right, same thing as before. We're gonna do a 1 millimeter resolution scan. We need that density because we want to build this up on the rod, and for the depth of reconstruction, we're not going to be more than 2 or 3 meters. So I'll just leave it at 3 meters, and I think that'll be good enough. So let me get going here. I'm going to go save. Let me go ahead and scan. All right, so first I'm going to do kind of like an overall pass like that. I'm going to do a little bit more directed at the panel like this, like that. Okay, now I'm going to really go after just the trajectory rods and the spheres. So I'm looking at the depth map. I can see it's resolving on the spheres. There's a little bit of color on the spheres, so that's great. I'm going to go around this way and pass it along this way. Okay, so that looks good. And then I'm going to try and get on this side here, like that. And let's see what we get with this. Okay, I think that's good enough. All right, great. Like that. Okay, maybe a little bit extra. And let's leave it at that. Stop. Okay, I'm gonna save this one for later. I'm gonna stop the recording. There we go. I think I'm okay. So what are we gonna do? We have the data now, and we have two choices. One is that we can process on the cloud, and the other one is we can process on the device. So what I'll do is I'll show you how we process on the device, maybe with one of them or something like that, and then I'll show you all the data in Cloud Compare, and I'll put them side by side. I'll put the device process scan and the cloud process scan side by side. They're never the same, okay? There's always some tiny differences, but overall, both of them are suitable for doing, a trajectory analysis or something like that. So let me get processing, and I'll be back in a bit. Okay, so what I'm going to do here is some on-device processing, and for that, really all I need to do is go back into the scan and choose process on device, and you can set the settings that you want to use. So I'm going to turn this down to like 2 meters and just let it run through. The initial steps will run from 1 through 7. 1 to 5 are usually a little bit quicker, but then 6 is the one that's going to take a really long time. And so what I'm going to do is I'm going to stop the video and just kind of make it go a lot faster, so you'll be able to see. So I'll put some music in the background, and once it's done, you'll be able to see the result, and later on I'll bring it up in Cloud Compare. Okay, so we are in Cloud Compare here, and I have 4 sets of data. All the data has processed, and the way I have divided these up is on the left side here, we have the rods only that were on the vehicle. The front is the cloud process model, and in the back is the device process models. And you'll see right off the bat, there's a couple little differences. If we move to the right side, same thing here. So we have, this is the one with the rods and the spheres, and the cloud process model is at the front and the device process model is at the back. And again, you can see that there's some small differences. Now, when I process these on the cloud, I believe I had the depth of reconstruction set to 3 for the cloud model. And when I did it for the device model, like on the actual iPhone 13, and just so you know, it's an iPhone 13 Pro Max, I believe I set this at 2 meters. So that's, I think, why you're seeing a little less data out on the extremities here. But let's have a look and see what we found. And so let's start with the cloud process model. So one thing you'll notice is right off the bat, the 1/4 inch rod is longer, and it only has a small section here that it disappeared. And again, this depends on the technique that I used. Although they were similar, they weren't identical. I didn't do them exactly the same, but they were pretty close. And here you'll see on the 3/16 rod, the smaller one, it drops off over here, so it doesn't reconstruct out at the tip. And over here, closer to the vehicle, it also has a little bit of a problem there. If I go to the device model, you'll notice the same thing. I get a longer trajectory rod for the 1/4 inch, and for the 3/16, you can see that I have a smaller piece. So the 3/16 is right on the edge. I think it's a harder one to develop. So yeah, the 3/16 rod is going to be a difficult one to get. You need to really spend a little bit more time on these. If it's a 1/4 inch, then it's going to be a lot better. Also, I will point out, on the edges of the rod, you'll see that there's this noise here, okay? And you don't get that same result on the cloud process model. So there's some filtering that's going on the edges. With the extra horsepower of cloud processing, it cleans it up a little bit. However, it doesn't appear to be detrimental. So this rod that I have here would be perfectly fine for doing an analysis, and the same goes with this little one here. Just enough there to do the type of analysis for a bullet trajectory. Now let's look at the spheres and the rods. And in a similar fashion, if I look in at the cloud process model, you can see here that I've got a couple of spheres, and a little bit better formed. Now you see close to where the sphere ends and it gets close to the body, there's some distortion here. And over here, it wasn't even developed, so we don't even have the rod here. So that was a little bit trickier for the algorithm to reconstruct. But if I'm only looking at the spheres and not the rods, that's all that I need. So basically this sphere and this one and this one would be absolutely enough to define the trajectory based on the center of these spheres. So that would be no problem at all. Let's have a look at the device model here. So we have a very similar effect, a very similar thing. In fact, we have a little bit more data here, but we have this sort of halo effect where edges of the objects and such start to create a little bit of noise. However, the main part of the rod, the center of the spheres, look like they're fairly well constructed. And so I could definitely use that in a reconstruction. So that is pretty much it. That's the comparison. That's what you get. I guess the point here is that there are some differences between a cloud process model and the on-device process model, but nothing that's severely detrimental. And I think that's the important thing. And of course, with the device process model in the new version of Recon 3D, you can go back and process it again. So if you want to change the depth of reconstruction, if you want to change the resolution, maybe these were all done at 1 millimeter, but if you want to do them at 2, and then, maybe you're happy with what you got there, or maybe you want to push it a little bit further at 1 millimeter, then you can absolutely do so. So that does it for this video here. Thanks everyone, and we'll see you on another video. Bye-bye.